My name is Kumar Maradani, and today I'll be presenting my thesis on AI-powered demand forecasting for sustainable supply chains. The focus of my research is on how advanced AI models can improve forecasting accuracy in retails, reduce waste, and promote sustainable operations. I will be demonstrating this by using Walmart's historical sales data. Coming to the introduction, global supply chains today are highly complex and fragmented. For retailers, forecasting method accurately is critical, not only for profitability but also for reducing environmental impact. Inaccurate forecasting can lead to overstock, excess markdown, and waste, all of which contributes to higher carbon emissions. Traditional models like ARIMA are simple but have limitations. They often ignore multiple factors like store characteristics or economic indicators. AI models, especially machine learning and deep learning approaches, can process large multivariate datasets and capture complex nonlinear relationships, making them more suitable for modern supply chains. Coming to the research problem and objectives, the main problem is that many retailers still use traditional forecasting methods, looking at only past sales without accounting on for local demand patterns, promotions, or economic conditions. For my study, I used Walmart's historical sales data, which includes markdown events, seasonality, and store characteristics, to build AI models that can improve accuracy and efficiency. My main four objectives are forecast weekly product demand for each Walmart store using multiple variables, compare traditional ARIMA with AI models like Random Forest, XGBoost, and LSTM, quantify the sustainability benefits such as reduced markdown and overstocks, use explainable AI tools to make predictions transparent for decision makers. My central research question is how can AI-powered demand forecasting models enhance sustainability in supply chains by integrating stored characteristics, markdown strategies, and external economic features. This is important because it bridges two goals: operational efficiency and environmental stability. Coming to the literature review, the literature highlights the weakness of traditional time series models when handling nonlinear, seasonal, and high dimensional data. Ensembling learning methods like random forest and XGBoost often outperforms single models like in predictive stability. Here I observed my model with a different model and compared and noted in the table. And coming to the data set, my data set spans from 2010 to 2013 and covers 45 Walmart stores. It includes weekly sales, markdown events, store size, fuel prices, CPI, unemployment rates, and holiday indicators. The pre-processing steps included are merging multiple datasets, filling missing markdown values with zeros, encoding categorical features, creating time-based features such as month and week number. This ensured data quality, preserved seasonality patterns, and improved the predictive richness for model training. I used Python as the main programming language. For the data manipulation, I used Pandas and NumPy. For visualization, I used Matplotlib and Seaborn. The machine learning models were implemented using scikit-learn and XGBoost, whereas LSTM models were developed by using TensorFlow and Keras. For ARIMA, I used stats model library, and for interpretability, I employed SHARP, which allows us to explain model prediction. And then the models, the four models I implemented were random forest, a robust ensemble method, XGBoost, an efficient boosted regression technique, LSTM, a deep learning model designed for sequence data, ARIMA as a classical baseline. The workflow followed these steps: data cleaning and feature engineering, train test split, model training and evaluation using RMSE, MAE, R-square, and MAP, interpretability analysis using SHARP for XGBoost. Coming to the coding part, in the first step, I imported all the necessary libraries and then I loaded the four data sets like train.csv, test.csv, feature.csv, and store.csv. And then by using the shape attribute, I found the size of the each dataset, like train dataset size, test dataset size, feature dataset size, and show dataset size, like number of columns and number of rows. And then by using the .info function, I get all the details of the dataset, like how many null values in the train dataset have and what are the columns in the train dataset. And then by using the describe function, we can get in detail of the train dataset details, like mean value, standard deviation, minimum 25% value, and 50%, 75%, and maximum values. And then we converted the date column to date time objects. It allows us time-based grouping, and it enables us seasonality and trend analysis. And then I computed the columns for missing data. This steps involves clean and messy data. By using the dot is null, I get the missed values like this. As we observe that there is a missing values in the markdowns and the CPI and unemployment. So for the better for the better understanding of the models, I measured the datasets into one consolidated data frame by matching the date, store, and department. So I measured the datasets for this, and then I checked for the missing values, and we observed the markdown values have still missing values. So I implemented, uh, I implement, I inserted as 0 for the marking values as no discount is applied on that particular days. So I implement as 0. And then I used the info function to check the null values, and I found that there is no null values in my dataset. Now it's ready for the EDA analysis. And coming to the EDA analysis, I plotted a line plot which shows the total weekly sales over time. Here it shows that the sales in November and December are higher comparative to the other months. And I plotted a store type bar plot which shows the store A has higher sales compared to the store B and store C. And then I converted the dates date format, and then I used weekly sales trees trends by store type. Here I observed three different store types, and I found that store A has higher sales compared to the other stores, which shows that store infrastructure plays a major role in the sales volume. And then I plotted a plotted a bar plot which shows average weekly sales by store type and year. And then I plotted weekday sales patterns on holidays and non-holiday days. Like here I can found that by using this box plot, the non-holiday sales are higher compared to the holiday sales. And then I plotted a heat map to show the correlation between the features. And then I plotted the markdown by features. And then by using the monthly seasonality, we aggregate sales by month and identify seasonal trends. We can see that peak sales appears on November and December month due to holiday shopping, while the dips may occur at February month. The seasonal pattern is for key for forecasting. Coming to the machine learning models, random forest, we define our target weekly sales. Here the random forest model. Here we used the labeled encoding for converting the categorical data into numerical data, and each holiday is converted into the numerical format for better modeling. And then we define the target variables and input features, and then split the data by using train.test split. as 80:20 ratio, and then random forest random forest model is used. Random forest handle nonlinear relationships and interactions between features as well. We also evaluated the plots of actual versus predicted value. A scatter plot is evaluated and it shows that it fits exactly with the predicted values. And then coming to the XGBoost, and we also showed the import factors that affect the sales. And here we observe that the department has higher effect on sales. And then coming to the XGBoost, we trained the XGBoost as a powerful boosting algorithm as it is higher accuracy and speed. And then we found the calculated values of XGBoost MSC values and the R-square values. And then we plotted actual versus predicted values of the XGBoost by using a scatter plot. And then by using the LSTM model, we checked the min-max scalar, and then we got the MSC and R-square values from the LSTM model, and we plotted the actual versus predicted value of the LSTM model, and it's not performed well compared to the other two models. And then ARIMA and then the time series forecasting ARIMA model was implemented. Here I used the ARIMA model and I got the ARIMA values as RMSC 1893543.62 and MEIE values as 163148.05 and MAPE as 3.61. And then correlation with them. And then I plotted the ARIMA actual versus forecasted values here. And then I used the SHARP model and on XGBoost. And then I plotted the which markdown has highest features and all. And then coming to the model performance, Random Forest achieved the best performance with an R-square of 0.9776 and RMSE of 3417.75, capturing more than 97% of variance in sales. XGBoost performed strongly with an R-square of 0.9082 and trained faster than Random Forest. LSTM underperformed with an R-square of 0.9284 due to short training sequence and epochs. ARIMA was effective for long-term trends but failed due to resulting in extremely high RMSE. Coming to the feature importance, Random Forest and XGBoost both identified department ID, store type, and store ID as the most important prediction of sales. Markdown variables, especially Markdown 5, also played a big role, showing that well-targeted promotions can significantly increase sales. The SHARP analysis confirmed that these results are provided visual transparent explanations for each prediction. And then coming to the sustainability impact, from a sustainable perspective, better forecasting reduces overstocks while which in turn lowers markdown dependency and waste generations. Smaller inventory surpluses also means fewer truck trips, improving logistics efficiency and cutting the carbon emissions. And then coming to the conclusion, AI models, especially random forest, can significantly outperform traditional forecasting methods in retail. By comparing historical sales with the markdown, store attributes, and economic indicators, these models provide an actionable insights for suitable retail operations. And these are the references taken from, and thank you for giving this opportunity.